So today in 9.6, we are going to cover exponential equations and logarithmic equations, okay? Sometimes when you are solving an equation for x, let's say, sometimes the x is actually in the exponent. So there's two different options for this. The first option we're going to see on problems that at the beginning, like number 1, you've got 5 to the x power equals 3,125. So in other words, 5 to what power is 3125? So the first method we're going to use is if you can rewrite this side to be a base of 5, then that's what you're going to want to do. So if I can rewrite this side instead of 3,125 as 5 to a certain power, I'm going to do that. Okay, so in my calculator, that's what I'm going to do. I'm just going to start checking. Let's see, 5 to the 3rd power. So I just need to go higher. I'm either going to land on 3125 at some point, or I'm going to pass it. So let's try 5 to the 4th power. Okay, so I'm getting closer. Let's try 5 to the 5th power. Okay, so I landed right on it, which means on that right side, instead of writing it as 3125, I can write it as 5 to the 5th power. I'm going to bring this left side down. If you can make the bases on both of these the same, then all you have to do is set your exponents equal to each other, which in this case is just x and 5, and then solve for x. And again, in this case, the x is already alone, which means 5 is your answer, right? 5 to the 5th power is equal to 3125. So that is the first method. If you can rewrite this side to be the same base as the other side, then you can just set your exponents equal to each other and solve them for x. Okay, let's look at number 2. We have 6 to the 9x power equals 1,296. So let's try this again. Let's see if we can write 1,296 with a base of 6, okay? I always just like to start with to the 3rd power, and if I need to go up or down from there. So 6 to the 3rd gives me 216, which means I still need to go up, right? So let's try 6 to the 4th. And that gets me to it, right? So instead of writing 1296 on the right, I'm going to write it as 6 to the 4th power. Bring this other side down. So once you make your bases the same, set your exponents equal to each other. So 9x equals 4. And this time I do need to do a little bit more work, right? I need to solve for x, so I'm going to divide by 9. So x equals 4/9. All right, let's go to number 3. Number 3 says 4 to the x equals 17. So can you rewrite 17 with a base of 4? Let's see. What's 4 to the 1st power is 4. 4 to the 2nd is 16. 4 to the 3rd is 64, right? So I pass it right up. In other words, I cannot write this as a base of 4. That's why we have the other method. So remember on Wednesday when we talked about all the different properties of logarithms, okay? One of those properties was you can rewrite a log that has an exponent up here. And remember what we did on all those when they had the exponent? We brought it down in front of that log, okay? So we're going to use that property. Also, we're going to use the rule of solving any equations ever that I can do absolutely anything I want to one side of an equation as long as I do it to the other. So I am going to log both sides. If I log this side, I have to log the right side, right? If you do one thing, you got to do it to the other. And the reason I'm doing that is because of the log property that says if you have a log with an exponent, you can rewrite that, bringing the exponent down and multiplying it times that log. So in other words, now that's what's going to bring the x out of the exponent. So over here, I will have x times log 4 equals, just bring this down, log 17. So now that my x is down in the area that I want it to be, I need to isolate, right? You're solving for x. X is what you're solving for. So if this is x times log 4, how are you going to remove the log 4? You're going to divide by it. So bring down my x equals, this is just calculator work now. So what you're going to come up with is a long decimal, and they're going to want you to round it to 4 places. So let's just type that in our calculator. So in the numerator, and it's not log base, it's just a regular log, right? So I just hit my regular log button, 17. So when you do log, it's going to automatically open a parenthesis for you. So make sure now you shut it. Divided by log 4. So divided by your regular log button again, 4, and then close it. Hit enter, round to 4 decimals. So 1, 2, 3, 4. Let's see, after the 7 is a 3, which is just telling me I don't need to round up the 7. So 2.0437. Is what this x is, right? And doesn't that make sense? Because the original equation was 4 to what power equals 17? Well, 4 to the second power is real close to 17, which means my answer is going to be real close to 4 squared, isn't it? So look what your answer ended up being, 4 to the 2.0437. That's what that x is, just a little bit more than 4 to the second power. Okay, so we're going to use that as this method, or the first method is if you can write both sides of the equation to have the same base, we'll use that method. So let's look at number 4 and decide which method we can use. Okay, this method, the method that we just did, actually works on all of them. It's just easier if you can rewrite both sides of the equal sign to have the same base. Number 4, 3 to the 9x minus 5 is equal to 81. So let's see if I can rewrite 81. Let's start off with 3 to the 3rd is 27. You do in your calculator 3 to the 4th power, you do get 81, which means I can write both sides of this equal sign as a base of 3. So let's rewrite the 81 as 3 to the 4th power. Over here, I have 3 to the 9x minus 5 power. So since my bases are the same, I just need to set up my exponents to be the same. So here I have 9x minus 5 equal to the other exponent, which is 4. Solve it for x. So get rid of the minus 5 with a plus 5. So 9x equals 9 and divide by 9. So x equals 1. Right, number 5. Two to the x power equals 10. Let's see, 2 squared is 4, 2 to the 3rd power is 8, and 2 to the 4th power is 16, which means I can't write 10 with a base of 2, right? It skips it right here. This also tells me that when I find my answer, 2 to what power, it's going to be somewhere between 3 and 4, right? Because 10 is somewhere between 8 and 16. So it's going to be 3 point something. Okay? But I do have to use the log method, right? Since I can't rewrite 10 as a base of 2. So let's log both sides, because that's what's going to get my x out of the exponent. So I'm bringing my x down. So now I have x times log 2 is equal to log 10. Gives the x by itself, so you're dividing both sides by log 2 to cancel that. And here's my x equals, do it in your calculator, log 10. And remember, since the log automatically gives you that open parenthesis before you hit divide, you need to close it. Divided by log 2 and close it. Now remember, I've already realized that since the 10 would be right here, I'm going to have 2 to the 3 point something, right? That exponent needs to be 3 point something. So when I hit enter, and there it is, go to 4. Oops. What am I doing? Oh, I forgot my log. I mean my division. Log 10 divided by, which is important, I forgot to put that, log 2 and close it. So there is your 3 point something. So we're pretty sure, we're pretty confident. 1, 2, 3, 4. After the 9 is a 2, which just means you don't need to round up the 9. So 3.3219. Okay, number 6. To the negative x equals 9 to the 5x. Okay, I'm not going to be able to rewrite these with the same base. Okay, so I am going to log both sides so that I can get my x's out of the exponents. I'm going to bring both of them down, right? So now let's see, over here I have negative x log 10 equals, bring this one down also, so 5x log 9. So we are solving for x. Here's the thing, anytime you have x and it's in 2 different areas, combined in 2 different terms, and those terms are not like terms, so I can't put them together. Right? These are not like terms. One's a log 9, one's a log 10. So I can't put them together. They're not like terms. However, you do want them on the same side as each other. So the first thing I'm going to do is, either way, I'm going to move this one over here. And that's just because that'll keep my x's positive. You can move this one over here if you wanted. I'm actually going to move this one over there. So plus x log 10 plus x log 10. So it cancels it over here. I don't have anything left over here. So there's a big fat 0. Equals, again, they're not like terms. I just wanted the x's on the same side, and you'll see why in just a second. So I have 5x log 9 plus x log 10. So here's why you want the x's on the same side as each other, because look, now they are the common factor between the terms on the right side. And what can you do with common factors? You can pull them out of both of the terms. That is what's going to give you just one x, right? Here, since I see x is in both terms, I'm going to pull the x out, put in parentheses what is left. So if I took the x out of here, I'm left with 5 log 9. Plus, if I took the x out of the second term, I'm left with log 10. So again, putting the x's on the same side, made those be the greatest common factor, which means I could pull it out, put in parentheses what's left. That makes you just have one x now. You can isolate it. How do I get this x by itself? Well, I just divide by all this mess. 5 log 9 plus log 10 to cancel all that. If I do it over here, I've got to do it over here. Remember, all I have is a 0 on the left side. So when I divide by 5 log 9 plus log 10, I really don't even need to put this in my calculator. Look at your numerator. 0 over anything, doesn't matter what this is always 0, right? So on the right, there's your x all by itself. 0 over anything is 0. Okay. Number 7. E to the t power equals 395. So what we're solving for is in the exponent. This is using an E. So instead of logging both sides, let's remember what the natural log is, or log base E is L. We're going to do ln on both sides. So if you have an E as part of your equation, instead of logging both sides, just ln both sides. And I'll show you why in a minute. So let's see, just like logs, this is a log, right? That's just log base E, or the natural log. It also brings the exponent down. So on the left, I have t times ln E. On the right, I have ln 395. Here's why we want to ln both sides, because ln E is equal to 1. Okay, remember what ln is? It's log base E. Well, if this says log base E of E, what is that saying? What power do you have to raise E to make it E? Well, what power would you raise something to not change it? The first power. So that's why anytime you see this right here, you can kind of cancel it out and think of it as just being 1. So let's see what's left here. Just the t equals. On the right, all I have is ln 395. So let's just punch that in our calculator and round it to 4 spaces. So on, clear it out, Remember, there is an ln button on your calculator. So ln 395. Close it, enter, round it to 4. So 1, 2, 3, 4. What's after the 8 is another 8. So what does that mean? I need to round that 8 up to, I need to round it up to 9. So I'll have 5.9789. All right, number 8. E to the negative 0.12t is equal to 0.17. Solving for t, anytime your unknown variable is in the exponent and you can't rewrite your sides with the same base, you're going to log, or in this case, natural log or ln both sides. This comes down. Negative 0.12t times ln e equals, just drop this side down, ln 0.17. Now remember, what is ln e? It's 1. So in other words, I just have negative 0.12t times 1, which means I don't even need this. I'm getting this t by itself, which means I will divide by negative 0.12. That'll cancel that. That'll be my t all by itself, which is what I want. Let's type this in. ln 0.17. There's your ln. 0.17 divided by negative 0.12. I'm going to put that in parentheses too. I don't know if you necessarily have to, but in the bottom, negative 0.12, close it. Uh-oh. What do I do? Oh, see what I did? I forgot to put, look what I forgot to do. On the top, I forgot to close out. So I had an open here without a close and then another open. So I've got to just fix that. ln 0.17, close it, and then divide it by negative 0.12. Okay, so I just forgot to close. I forgot that parenthesis right there, which messed up the whole thing. So 14.1234 after the 3 is a 0, which means I don't need to round up the 3. So 14.7663. All right, number 9. We've got 12 to the x equals 4 to the x plus 2. Okay, solving for x, and it's in the parentheses. I can't rewrite 12 as 4 to a certain power. So I am going to have to log both sides to get those x's out of the exponents. So here the x comes down. So I have x times log 12. Now, over here, it brings this whole exponent down, right? So I'm bringing down x plus 2 times log 4. Now, here's the reason I put the parentheses around that x plus 2. If not, the only thing you would be multiplying times that log 4 is this 2. This whole thing is coming down. So on the right side, both of these are times log 4. The x and the 2. So let's write that out. So the first thing I have is x times log 4. I also have plus 2 times log 4. So I'm just going to bring those down. Let's just bring this side down to where we are. So what are we solving for? We are solving for x. I notice once again, I have x. It's in two different terms that are not like terms, so I can't put those terms together. But remember, we do want both of the x terms together on one side, because if they're together on one side, what can you do? You can pull the x out as the greatest common factor. So I'm going to put this x term over here, so it'll be with this x term, and then I'm going to pull out the x. So let's see, if I'm going to move this over here, I need to subtract x log 4 from both sides. That one cancels. On the left, I have x log 2 minus x log 4. I'm just going to bring this side down, 2 log 4. So again, the whole reason we moved this x term over here is so that we would have all our x's on one side, so we could pull out the x. Thank you, thank you, thank you. Yes, so when I brought this down, it's x log 12 right here, and not x log 2. So x log 12 minus x log 4, so they both had the x in common. So since they both have x in common, I'm going to pull out the x and put in parentheses what's left. So if I took the x out of this one, I would just have log 12 minus, if I took the x out of this one, I'll have log 4. Equals, over here I still just have 2 log 4. So the whole reason to put those x's over there and pull out that x is now I can isolate the x by dividing by this whole thing right here. So I'm dividing by log 12 minus log 4 on both sides. To cancel this. So there's my x all by itself, which means this side will give me my answer. Be very careful when you're putting this in your calculator. Let me show you what I'm talking about. Uh-oh. Okay, so I'm all caught up, right, Abby? Thank you. So on the right side, I need to type in 2 log 4 on the top. So just type it in just like that. 2 log 4. Now remember, what does it do when it gives you a log? It gives you an open parenthesis. So before we divide, we need to make sure we close it out. Then divided by. Now, on this side, what you're going to want to do, because remember, when it gives me this log here, it's going to give me an open parenthesis that I'm going to have to close behind the 12. It's also going to give me an open parenthesis in front of the 4, which I'm going to have to close behind the 4. Now, I'm also wanting to tell my denominator to keep all this together as one denominator. So that's the trick to this. Before I start typing, I'm going to need to put in a parenthesis here, log 12, close the parenthesis behind the 12, minus log 4, close the parenthesis behind the 4, and then you're going to have to put in another closed parenthesis to close out this parenthesis. So type it in exactly like it is on the board in the denominator. So before you type in anything, type in the first open parenthesis, then log 12. And then after the 12, you're going to have to close it. Minus log 4. Remember, after the 4, you're going to have to close that log and then another close to close out the whole denominator. Hit enter. Round it to 4 decimals. So 1, 2, 3, 4. After the 7 is a 1, which means you don't need to round the 7 up. So 2.5237. Now, starting with number 10, we're going from exponential equations, where our x's were in the exponents. We're going to logarithmic equations, which means on this one, we put the logs in those equations for the purpose to bring down the x. But starting with number 10, the original equation is going to have a log in it. Okay, so we're going to have to remember what we learned on Wednesday. Looking at number 10, we've got log base 2 of x equals 2. I can turn this anytime you're solving a log equation and you just have one log involved in the whole thing. You want to say, okay, I know that I can turn this into an exponential equation by doing the base to that power and make it equal to what you're taking the log of. So rewrite this like that. What is this saying? 2 to the second power is equal to whatever you're taking the log of. Well, that's your x. These two things say the same thing, right? 2 to the second power equals x. Well, what is 2 to the second power? It's 4. So 4 is what x equals. So again, if you have just one log, raise whatever its base is to this power and put it equal to what is in this spot right here. And then solve it. We're going to do the same thing on number 11. Log x equals -4. Okay, so what did I just say? I said if you have one log, you're going to raise its base to this power and set it equal to this. Well, this one, what happens if you don't see a base? That automatically means that you are log base 10, right? So it's going to be 10 to the -4 power is going to be equal to x. Okay, you can type that in your calculator, but it's going to give you some funny answer that Math Lab won't take. I'm pretty sure, I think, unless my calculator is in some kind of weird mode. But what does a negative exponent mean? That means I need to fix it by flipping the base. So I need to think of that as 10 over 1, so I can flip it upside down to 1 over 10, turns my exponent to +4. So now I have 1 over 10 to the 4th, which is just 1 over, and if you wanted to type that part in your calculator, 10 raise it to the 4th power gives you 10,000. So you can either enter it like this, 1/10,000th or 0.0001. Those both say the same thing. Number 12. Log base 2 of 2x minus 8 is equal to 4. So once again, 1 log means raise its base to that power. So 2 to the 4th power and make it equal to what is right there. So that's going to be equal to 2x minus 8. And then solve it for x. Let's see, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th is 16 equals 2x minus 8. Solving for x, so I just need to add the 8 to both sides. 16 plus 8 is 24 equals 2x. And divide that by 2. So x equals 12. Number 13. Log x plus log x plus 21 equals 2. So this one's different, and it's different because I have 2 logs on one side, which is another reason that we did the log properties on Wednesday, because now I know I can rewrite this as 1 log, right? We did this several times on Wednesday. How if you're doing the sum, since it's adding, and I rewrite this as 1 log instead of 2, that means I'm going to need to multiply the x times x plus 21, right? That's what that property is. That's what switches back and forth between sum of 2 logs can be rewritten as 1 log with the x times x plus 21. So if you have 2 logs and it's a plus in the middle, rewrite it as 1 log and multiply the 2 things you're taking the logs of. So now I can do, now I'm down to 1 log, which means I will do whatever the base is, since I don't see it, it's a 10 to this power. So 10 squared is equal to whatever is in this position right here. Okay, so I'll have x times x plus 21 there. So let's see what we have. 10 squared is 100 equals, I need to distribute the x here. So that's going to give me x squared plus 21x. This makes it quad, right? Since it's x squared, which means when you're quad, you want all the terms on one side. Then I can go to my quad program and punch in my A, B, and C. So I need to subtract the 100. So now I have a 0 equals x squared plus 21x minus 100. So now, since it's an x squared equation, I'll go to my programs down to quad. Type in my A, B, and C. In front of x squared is my A, which is a 1. B is 21. C is negative 100. Now, look what it gives you. It gives you 2 solutions, 4 and negative 25. Now, when you get two solutions, you need to check. Be careful, because if one of those solutions is negative, what if you put negative 25, right? We're solving for x. So if I put negative 25 right here, what does that mean? I'm taking the log of negative 25. Remember when we were doing that, when we very first started about doing logs and you were taking log of a negative number, it would give you no solution, which means negative 25 is not a true solution. Only the positive one is. Okay, 14. All right, we're going to be really close to getting this done. On 14, we've got log base 3 of s plus 14 minus, this time, log base 3 of s plus 6 equals log base 3 of s. Okay, so anytime, here's my equal. Anytime you have two logs with the same base on one side, turn them into 1. Now, since I'm turning them into 1, that means I need to see, are they added or subtracted? This time they are subtracted. What does that turn into? That turns into the quotient, right? 1 over the other, not multiplied. If this is add, that's when you would turn them into multiplying those two together. But since it's subtracted, it's going to turn into 1 log. So log base 3 of s plus 14 over s plus 6. Just bring down this other side, log base 3 of s. So something else we haven't seen, even though we turned this side 2 logs into 1, I've got logs on both sides. Now remember, this is still an equation. I can still use all my solving equation rules. Well, if I've got the same log on both sides, I'm just going to divide it off to cancel it. Log base 3, divide there, divide this side by log base 3. So that canceled the log base 3 there and there. So let's see what I have left. On the left side, I still have s plus 14 over s plus 6. On the right side, I have s. Okay, now I'm solving for s. So this does look like going to be a hard thing to solve, but remember the cross multiplication rule of solving equations. If you have one fraction equal to one fraction, which I can just put that over 1 and make it the fraction I want it to be, you can solve that by cross multiplication. Which means when you're cross multiplying, the multiplication of one diagonal is going to be equal to the multiplication of the other diagonal. That's going to make your not be fractions anymore. That's what cross multiplication does for us. So on this one, if I go, it doesn't matter which way you go first. If I go this way first, I'm multiplying the s times both of these. So s times s gives me s squared plus s times 6 gives me 6s. So there's one diagonal. That's going to be equal to the other diagonal. So if I multiply these times 1, it's just going to stay s plus 14. So again, now I don't have fractions, but I do have the squared, which means it is going to be quad. So before I plug in my A, B, and C, I need to move these over here. So I'm going to subtract the s and subtract the 14. Because Because remember, in order to use quad, you got to set it equal to 0. So on the left, I have s squared. 6x minus s gives me plus 5s. Bring down the minus 14. There's your A, B, and C that you're going to plug into quad. So A is 1, B is 5, C is negative 14. So be careful when you get that negative answer, 2 and negative 7. Right here, think about this. If you put the negative 7 in place of this S, you'd have negative 7 plus 14. So that one would actually be okay because that would end up being positive. But what happens if you put the negative 7 here? Negative 7 plus 6 gives me negative 1, and I can't take the log of a negative. That's an error. So that's why that negative 7 is not a true solution. All right, number 15. Log base 4 of x plus 1 minus log base 4 of x equals 4. All right, 2 logs on the same side, which means I need to turn them into 1. So since this is subtracting, one's going to be over the other. So I'm going to have log base 4 of x plus 1 over x equals, just bring down your 4 over there. So unlike the last one, I don't have logs on both sides, so I can't just divide them off. So this is that original rule that we talked about. Once you get to just one log, turn it into the exponential equation. So whatever your base is, to that power, so 4 to the 4th power is going to be equal to whatever is right here. So I have x plus 1 over x. So let's see on the left, what is 4 to the 4th? Gives me 256 over here. Equals, still have x plus 1 over x. Now, remember, just like we did a couple of problems ago, just make this a proportion and do cross multiplication. Right? That's what happens when you have a fraction that's got x's all over the place. You just want to do cross multiply. So let's go this way first. Doesn't matter which way you go first. So 256 times x just gives me 256x equals this way. If I'm multiplying these both by 1, I'll still just have x plus 1. Now it's not quad, right? It's just x. There's no x squared. So we just want to get the x by itself. So let's subtract the x from both sides first to get all my x's over here. So now I have 255x, right? Because 256 minus 1 gives me 255x equals 1. Get x by itself, so divide by 255. So the x is by itself. What's left on the other side? 1 over 255. All right, 2 more. So we are going to go just a little bit over. But it's better to make it all one video. We want to save one problem for Monday. Number 16, log base 5 of x plus log base 5 of x minus 2 equals log base 5 of 8. All right, on the left side, rewrite your logs as one log. This time they are added, which means when I write it as one log, it's going to be x times x minus 2. I've got log base 5, x times x minus 2. Just bring this side down. Log base 5 of 8. Now, even though I turn this 2 logs into 1, I still have log base 5 on both sides. But remember what we did when we had the same log on both sides? We just canceled it out, right? Just divide it off. Log base 5. And this will cancel it. So all I have left here, I'm going to distribute this x. That's going to give me x squared minus 2x equals, all I have left on the right is 8. When I distributed this x, it gave me x squared, which turned me quad. So I want to set it equal to 0, so subtract the 8 from both sides. So there's my 0. On the left, I have x squared minus 2x minus 8. So when I am going to put that in quad, right, since it's x squared to get my 2 solutions. So go to program again, down to quad. Type in your a, b, and c, which will be 1, -2, and -8. So that gave me 4 and -2. So if either one of those turns my log negative. So what if you put the negative right here? Well, it's just an x. So log base 5 of -2 is going to give you a no solution. So that's why that one doesn't work. And 4 is your only answer. All right, last one, number 17. Log base 3 of x plus 3 plus log base 3 of x minus 3 equals 3. So again, 2 logs on the same side. Let's rewrite them as 1. Since it's plus, my 1 is going to be x plus 3 times x minus 3. So log base 3 of x plus 3 times x minus 3 equals 3. So it's not like the last one, right? The last one, well, even after I did that, I still had a log over here. So I divided them off and canceled them. But what's the method when you just have one log? Turn it to exponential. Whatever your base is, raise it to that power. So 3 to the 3rd power is going to be equal to whatever is all in this position right here. So x plus 3, x minus 3. And then let's solve this. So let's see, 3 to the 3rd power gives me 27 equals, I am going to have to distribute or FOIL here. Let's see, x times x gives me x squared. X times -3 gives me -3x. My inside, positive 3x. And my last, positive 3 times -3 is -9. These middle 2 terms cancel, right? -3x plus 3x. So let's see, what do we have on the right now? X squared minus 9. Drop down my 27. While in the process, it did turn quad. So let's move the 27 over here. So subtract the 27. So 0 equals x squared minus 36. So this one is quad. Just be careful when you're typing in your A, B, and C. A is in front of x squared, which is 1. B is in front of x. Since I don't have an x, my B is going to be 0. My C, which is the constant, is negative 36. So when I put 1, 0, and negative 36 in my quad, it gives me 6 and negative 6. But the negative 6 would turn this right here and this right here, for that matter, negative. So that's why we don't like that answer. The only true solution is positive 6. Okay? All right, so that is the end of 9.6.